Hello class, we're going to solve absolute value inequalities. And I'll start with the definition. Absolute value of x is less than some real number a. By definition, this just means x is between the opposite of this positive real number a, negative a, and a. So if we wanted to solve absolute value of x minus 2 is less than 3, we would simply write x minus 2 is between the opposite of 3, which is negative 3, and 3. So now we have a three-sided inequality. To solve a three-sided inequality, you can cover up one side, and you can see to solve for x, we'd add 2. But now we need to add 2 to all three sides, which gives us negative 1 is less than x, and x is less than 5. To graph this solution set on a number line, it's the open interval from negative 1 to 5. So we have infinitely many answers to our initial problem. Okay. For example, 0 would be a solution, 4 would be a solution, square root of 2, just all the real numbers between negative 1 and 5. In interval notation, our answer looks like the open interval from negative 1 to 5. And in set notation, it's the set of all real numbers x such that negative 1 is less than x and x is less than 5. Now, if we had, instead of absolute value of x less than a, we change that to absolute value of x is greater than a, we have to use an OR definition. That means x is greater than a or x is less than negative a. So if we have the absolute value of x minus 2 is greater than 3, we need to solve x minus 2 is greater than 3, or x minus 2 is less than negative 3. So the inequality sign switches and we have a negative number. So we change two things. Add 2 to both sides and we have x is greater than 5 or x is less than negative 1. Solution set on a number line, it's the open interval from negative infinity up to negative 1. Open interval from 5 to infinity, written in interval notation, negative infinity to negative 1, union 5 to infinity. Written in set notation, at the set of all x such that x is less than negative 1 or x is greater than 5.